So, hello, my name is Beata. I would like to welcome you on the track 3. I will be your host today. And just in a minute, we will be welcoming onto the stage Naor and Felipe Duarte of Security Jobs with a presentation entitled Sockbot and Goland, Linking APT Actors with Ransomware Gangs.
A11? Okay, we're good.
Okay, hello.
You have the remote?
Yeah,
Great, okay. Hi everyone, thank you for having us here. That's my 4th time speaking in confidence. With me is Felipe. We are from Security Joes. We are an incident response team. We are 24/7 incident response team. We have a team all over the world in Australia, New Zealand, Philippines, India, Colombia, Israel, Europe, and we basically have this full cover for our clients around the world. Hence, we are facing a lot of incidents all the time, conducting the forensics investigation and the malware analysis. And today we are going to speak with you about one of these incidents that we believe it was unique rather than others. And we compiled this research about it, and this research is also online. So if you're missing out anything or you think you have questions, so you just look for that headline online and you can find the entire research with all the bits and bytes. So this attack that we experienced on one of our clients, it started in like this one Friday when, you know, it's like this, how attackers like to, you know, conduct their malicious activities over the weekend or over these places with holidays and so forth. And we immediately felt like there is a propagation inside one of the client's networks. And we started investigating it. We found out unique malware that was not exist anywhere else prior to this investigation. So this is what we are going to talk about today, Sockbot and Goland.
Hello guys, hello everybody. For me, it's a pleasure to be here. So I'm Felipe Duarte. You can find me in Twitter as DarUpCos. Currently, I'm working as a senior cyber researcher at Security Joes. Some certifications, I have CEH, also GREM from SANS. I am an incident responder. I do love to analyze malware. So if you have any question related to malware, I'm with you. Also, we are going to have a workshop tomorrow, just in case. You are all invited. And I do love to share everything that we find with the community, with all of you. So this is me.
My name is Ido. I'm the co-founder and the CEO of Security Joes. I'm also an incident responder, a malware analyst, a reverse engineer, and so forth. I have a better title. I'm a parent for 3 daughters. I'm 37 years old, from Israel. And I'm also part of the CFP committee. So if you get bored, it's because I picked myself into this. No, I'm kidding. Let's go.
Okay, guys. So first, before we start digging into the details of the talk, we have 4 different items or bullets related to it that can describe the overall attack. Okay, first, we discovered that during this intrusion, basically threat actors use stolen credentials.
You can look at the TV.
Okay, good.
Go.
Basically, threat actors use stolen credentials to access to RDP, to the infrastructure via RDP. Okay, so in this case, there wasn't any kind of exploitation, just stolen credentials to access the services. Okay. Also, one thing we discovered is basically that there were some similarities between this attack and the modus operandi of some Russian-speaking ransomware gangs. These similarities were found mostly in the techniques, the tactics, and the tools that we discovered in the intrusion. Third, we found 2 unique Goland binaries. We didn't find those binaries in any other previous report. That's why we decided, or we found this interesting to share. And the last part is that this attack was specifically affecting the gaming and the gambling companies, basically in Europe and some in Latin America. Okay?
And when we approach an investigation, it is very important for us to make everything very intuitive for the reader, for our clients, for those who like to read those blog posts. And we are always on the hunt for tools that will help us to craft all of this timeline. And this is maybe a recommendation for you. We found something that is called draw.io. That's a website which you can create those interesting timelines or any other scheme or I don't know, sketch that you want to do. And it contains all of those features that you see. So if we look at the timeline, we can see that the attackers started somewhere here on this Friday, and they infected around 50 machines very swiftly with some PowerShell script. However, this PowerShell script was there in the Cobalt Strike payload. Over here, when we were investigating, we didn't see all of this chain. When we started investigating and putting everything into a documentation, then we were able to actually build all of this chain of events. So as you can see, what the attackers were doing, they were stealing credentials from one of the employees, and they found themselves in the network. However, when they found themselves in the network, in the computer of that employee, they could not enter the internal network. They did not have the right credentials. So they needed to deploy tools. Here we have like one of the Goland tools that Felipe is going to talk more about. We have Mimikatz and Lasagna. Those are very interesting and very known local privilege escalation tools to harvest credentials. And they did all of that in order to create this proxy, and from that proxy to talk to the internal network and propagate inside. So this is the timeline. Let's go inside.
Okay, perfect. So to understand a little bit more clear about this, get more insights about this incident, first, the threat actor started just to, once they got access, they needed to identify different targets inside the network, okay? So the software that they used to do that actually was, they used two specific tools. One that is A-define, which is not malicious per se, is a tool that allows you to get information from Active Directories. So once they infected one machine, they started to query the Active Directory looking for additional information related to users and more machines in that Active Directory. The other tool that they use is called NetScan. It is a tool developed by SoftPerfect, so it is also a non-malicious tool. And here is one thing important. Threat actors are moving. Sometimes they are not using just malware. They are using tools that are trusted by us, by defenders, and they are employing those they are abusing those against us, okay? So take that into account. That is a trend. They use SoftPerfect, and they started just to scan the network looking for services, specifically RDP sessions, so take that into account. RDP is one of the ways they are they are abusing to move laterally with
Before you move to the next slide, I just want you to focus your eyes on the sidebar, okay? Because we actually identified those tools being used with other threat actors. This is actually the headline, linking between APT actors and ransomware gangs. So I know it's a little bit blurry, but for example, this was part of Operation White Stork as well, using the same tools, and it was published by Awake Security.
Yeah. Perfect. So in the previous slide, we saw which tools they use to start discovering the environment, gather information related to the machines. So they got information related to the infrastructure. Now they needed credentials. Okay, why these credentials? They just want to keep digging and keep finding new additional assets that they can control. Okay, to do that, actually they use this tool It is called account restore. It is a .NET file. We didn't found any report related to this tool as well, so this is a new tool that they have in their toolkit. And this basically allows them to brute force all the local users inside the first compromised machine, okay? So this was also something super interesting. If you see in the left, you will see the software that we're talking about in green. It is highlighted in red. But that was mainly to brute force users. So they wanted more password users to continue with the attack.
Something worth mentioning about this tool, it was written in .NET. So if it's not obfuscated or not protected, you can basically easily decompile it, right? Java, .NET, C#, you can decompile, comparing to C++, C, other languages which are working through compilers that are not easily reversed. So you need to learn the practice of reverse engineering. In this example, we can see that this file load function is getting this password text for the action that Felipe was talking about, the brute force of password. We can see also that there are the list of users and the list of words, and there is some sort of a good list, which means that they found a match. Another very interesting area for those who read Russian, like myself, by the way, I used to work for Kaspersky 6 years, but this is not where I learned Russian. I was in a boarding school when I was 14, and this is where I learned Russian. There's a lot of Russian people in Israel. I don't know if you know, but in the 90s, a lot of Russians came to Israel, and somehow in the boarding school, I was very curious about the Russian language. So we can see here that it says, it's hard, Administratori domenia. Okay, so it means domain administrators, or maybe someone here that speaks Russian can tell me better, yeah? Okay, I see the way, all right, we're good. So domain admin, and I don't know, or we don't know if that means that the individual who created this malware was originally from Russia. However, it does shed some light around the origin of the tool and links us to some suspicious activity that we saw later, linking us to Russian-speaking ransomware gangs.
Okay, perfect. So another tool that we found in this attack is an open source tool. You can find it in GitHub. It's called Lasagne. This tool is more kind of a framework. Actually, it has some plugins for different services, but it allows you to dump as much passwords as possible. You can dump passwords from games, chat emails, like FTP clients, web browsers. You have a lot of options. They have plugins, and there is a community working on that. The project itself is just like it's an open source alternative to get to have a backup of your passwords, but is abused by threat actors. One thing that we see here in this picture, you can see these commands that are extracting some of the registry types or the machine, which are the security, the system, and the SAM. Those commands were run by Lasagne. However, at the time they were executed, they didn't have the privilege. They couldn't extract those hives. However, this tool allows them to get all the possible passwords from the compromised user, okay? So that's important. They were just like gathering and gathering more information related to the users that, all the services that the compromised machine uses, and they were then trying to use that to continue with the attack, okay? So this is, now we can understand a little bit more of the mindset of the attack. So they were discovering first, then gathering as much information as possible from the victim to continue, okay? Talking about the Goland binaries, this is the first Goland binary that we found. It's interesting, it's called Elsa's Dumper, the name you can find it there highlighted in red. It is simple It's a simple process that dumps dumps passwords from memory, specifically from the process ELSAS. But there is one differentiator here for this specific binary. It uploads automatically the results to a service that is called transfer.sh. Probably some of them are familiar with that service, but this is a differentiator of that binary. Also, when this file was analyzed, we found that it is very verbose. So you just execute this binary, and it's always telling the traductor in the console, okay, I'm dumping the memory, I'm starting to load, everything was good. It provides everything in the console. So this is the first binary. We didn't find any report previously in which this tool was previously described. Okay. At this point, because we also wanted to help you, help the community, like if you are facing this threat, so we decided to move forward and starting building a YARA rule, which is this one.
So why building a YARA rule? First of all, YARA is one of the most powerful programming language for malware analysts and threat intelligence analysts. Because basically, its purpose is to search in binary files. Of course, we can do a lot of magic with YARA. Some people even had presentations in conferences using nothing but YARA. But the main thing with YARA is that you can basically very easily search in binaries. So before we start explaining about what's inside the YARA rule, for those of you who don't know what the YARA rule is, let's explain a little bit about what it is. So we can see that it starts with the word rule. This is where the YARA programming language understands that it needs to parse that data to get some insights from within a matched binary. If you don't have any libraries that are being initialized before that rule, then it starts from there. Then the name that is basically manually can be crafted by you, whatever you want to call it. We call it, for example, Windows Goland Stealer ELSAS dumper, just like the binary. Afterwards, you have the curly brackets, and you have to close them as well. And three main components. One is the meta, the other one is the strings, and one of the most important ones out of the three is the condition. Okay, so basically, if you look at the rule, it goes from down up, because over here we have the calculation, like the mathematical routines and so forth. Over here, the strings, and you can enter other stuff I will talk about, and the meta, which basically does not give any automatic insights. It's a manual area of metadata that you can basically write whatever you want. So over here, we can see that Felipe wrote this YARA rule, and he decided to write the author because, all of us, this is basically how it happens in the industry. A description about what this is and a hash for those of you who will be interested in searching similar files like the ELSAS dumper, will understand what was the original sample that we started investigation from. In the strings area, you can see that all of the strings are starting with the $sign. This is a must, okay? Inside those initialized variables, don't have to start with strings. You can also use regular expressions, or you can also use opcodes. If you're very familiar with reverse engineering, you can basically take that binary into IDA or your favorite, and you can look at the opcodes. If you want to jump between opcodes, you have to use the question mark and so on and so forth. There's a lot of ways. Afterward, you have modifiers, which we don't see them. They will also be in purple, and you can basically look for strings with case or without case, full word, and so on. You can see that in the conditions area, there is some mathematical routines that you can do, but you can also look for count repetitions. So if something repeats itself a few times and so on, is an interesting part here. Let's look at what we have in the strings. So this basically is something that happened in the compilation of the Goland. So this, for that specific sample, it has to appear. So if we find something similar, it also has to appear in that file. That's why we are looking for that specific string. The other ones, you can see that they are matching each other. They are starting with the main. That is because they are part of the functions of that unique sample. And those functions, among others, are the unique ones, the ones that we are looking for. Strings 6 and 7 are basically embedded in the code. Felipe was talking about transfer.sh, and once you execute this file dynamically, those strings appear. So this is why we want them here. Now, sharpen your ears, because this is the hard part. uint 16 in the place of 0 is an unsigned integer in the size of 16 bits. And we are starting from the beginning of the binary. We want to start from the beginning of the binary because this is a method of understanding the header of the file, the type of the file. In this case, 0x5A4D, probably you're already familiar, the magic header MZ of an executable. And all of them, when we are referring to all of them, this is basically a condition inside YARA only, and it refers to all of those strings. So to find a match, we will have to find all of those strings inside the binary that has similarity to this binary that we found.
One thing to notice for any of you that probably is asking, okay, what do you call it, else's dumper? The string else's dumper main.go basically is the name of the package, the Goland package that the threat actor used in his machine, her machine, while he was developing the software. So that's why that's the name that threat actor gives to this tool. Then moving forward in the attack, this is where we found the second interesting Goland binary. And this is the reason why this talk is called Sockbot in Goland. So if you see the string over there,
PDB.
actually.
The PDB.
The PDB, yep. If you see the PDB of this file, you will see the whole path where the developer was, the threat actor was developing this project. And the name he assigned to the project is Sockbot, and he developed this in the IDE, Goland from JetBrains.
Not to be confused, Goland and Golang, the language, and the IDE.
Goland, yeah.
It's not a typo.
Yeah. So this was interesting. Actually, when we were doing the research, we found 4 different files at the time we were analyzing this. Currently, we are tracking it to get more insights. But we only find one binary with the name Sockbot. Previous to that, we have some versions in which this guy was just using the name Ligolo. So what's Ligolo? This Sockbot is basically a customized fork of an open source project written in Go that is called Ligolo. It is a reverse tunneling tool that, as I told you before, is open source. You can find that code in GitHub.
If you remember the timeline, then we showed you that the attackers stole passwords, and then we saw PowerShell running. We didn't know how they got into the internal network, and this is where this Ligolo comes in.
So before understanding what this new variant does, so we need to understand what the base code of this threat operates, how it operates, and what kind of stuff this code could perform on an infected machine. Okay, so Ligolo, the open source project, actually is a lightweight framework to establish SOF5 or TCP tunnels. Here is something important. There is a trend also that basically threat actors are starting to abuse a lot these kind of tools. So I don't know how many of you have worked with tunnels, protocol tunnels such as SSH. You can use, you can create an SSH connection, and then you can pass another service inside that. That's kind of, you can manage a lot of stuff using that. But threat actors notice that that is also a way to keep stealthy, like cover your tracks. This is something these guys are doing a lot.
You know, Felipe, 12 years ago, when I started my profession in cybersecurity, I started as a pen tester. And at that time, we didn't have remote work like post-COVID. So if we wanted to work remotely, we had to tell the client to place a laptop inside their network, and we had to reverse tunnel via SSH in order to do the internal pen test. So today, you know, you can basically think about remote as something that is very, you know, it's very obvious. But back in the day, we were using those type of tools for internal pen test remotely.
Moving forward, and this is something that it's nice to understand, to see what is the power behind these tools. Actually, if you see at the right side here, you see the client network. You see a machine which contains malware, or based on the documentation of the project, it contains something that is called the Ligolo implant. The implant is basically a small client that is run in one machine. Important, this client could run on Windows or Linux machines because the Goland binaries can be easily compiled between these different operating systems. So it can work easily without changing anything in each of these operating systems. Once you run the malware, in this case, in this investigation, that malware was running on Windows, and was the Sockbot. Basically, this opens the door for any attacker to access the internal infrastructure, and this door is open in internet. So basically what they are doing is exposing the internal infrastructure via the tunnel. They can expose any internal service such as RDP, which we mentioned before, that's super important, but also HTTP, FTP, any other protocol that they like. Even they can run Nmap scans with this kind of tool. So basically they are just open the door. This is the functionality of the malware in the infected machine. If we move to the attacker side, they do have a C2 server based on the documentation of the project. It is called the local relay. And this local relay is the one that is going to handle all of the connections to the infected machine. They can just tunnel everything in Linux using a tool. Probably some of you are familiar with that tool. It is called proxy chains. So if you have done some red teaming exercises, you will use that a lot. So they basically can use proxy chains and this infrastructure to access to any service that is running in the internal infrastructure. Now, so what was the modification? Why they decided to collect Sockbot? What was the modification, and what's the difference between the open source project and Sockbot? Basically, they added 3 things. First, persistence. By default, Ligolo, the open source project, doesn't have persistence. You need to run a command line to execute the implant. These guys, because they were running on Linux, they created a scheduled task. In this case, it is called Network Manager. And the file that we found was called socks and .ip. Okay? So that was the first modification. The second modification that they did, they added some checks before executing to avoid avoiding to execute the file multiple times. So basically, if the file was already running, they are going to skip that. The third modification, the open source project by itself, only you need to pass the address of your C2 server to make it work, and you pass that in the command line. These guys hard-coded the IPs, okay? So this was meant just to double-click, execute, boom, you have that. And once it has set the persistence, so every time the machine boots, boom, you have the proxy. So those were the main differences. Okay, important, this binary was super different from the previous Goland binary. This was to create the proxy connection. The previous one, else's dumper, just dumps passwords from memory and exfiltrates the data directly to transfer that SH. Those were the unique binaries. As I told you before, this is the place in which they hard-coded the C2 servers. Okay, if you compare the source code and this and this variant, you will see that actually they have almost the same functions, but in the original code, basically this the address of the C2 server was sent via a common parameter, an argument. Okay. Also, while we were doing the investigation, we found at least three additional more C2 servers. So it was a small amount, but also this was a new threat. And looking into those, looking for reports for those C2 servers, we found that there is one related to Cobalt Strike. So these guys are also using Cobalt Strike. They like that kind of tools. That is also one thing that matches with the ransomware gang modus operandi, which usually after they have compromised something, they move forward with Cobalt Strike. Important. This is the information related to one of the compromised machines. Look at the port 3389. They were exposing RDP. So they got access. Once they got access, discover additional devices. After that, they are starting to brute force users to get credentials. Then they expose RDP to internet. Boom, they connected using any RDP tool, and that was the mindset. Okay, so look, RDP, a trusted protocol, and that's why we at the beginning we didn't spot like the threat, because they were using trusted binaries, trusted protocols, not just malware. Okay. Just in case for you, if you want to track also this variant, this is the YARA rule that we created, as Ido said previously. It has the main structure. Basically, we are looking for those strings, and we're looking for the PE header.
So the last part of the chain of the attack is the part where I don't wish any of you to meet ever in your career. Not in your computer, maybe in the lab, but not in live and not in your client's network. What we are looking at here on the top is basically the PowerShell that we were looking at this Friday evening on 50 different machines, and it was highly propagating on each one of them. Immediately what we did is we used something that is only recently being adopted in the security industry. It's called isolation. And isolation is basically a feature in the EDR that allows you to block all the network communication from that specific machine to that sensor and leave only one open tunnel, one way to the cloud tenant of your choice. And so you can control and investigate this behavior. So we were looking at that, and you can see that the PowerShell has some keys, but the download string is the important area where it accesses Cobalt Strike beacon and basically displays this. There is a lot more to it in it, and you can see that this is a memory stream bytes, and it's encoded with a base 64 string. So once you decode it, click.
Yeah.
Not working.
It's not moving.
Once you decode
battery
it,
is running. Wait.
magic.
Boom.
Now. No?
Wait.
Wait, I need more magic.
Yeah, wait.
Okay.
Too much magic.
Once you decode it, then you see this code. And you know, the upper side is only like the beginning prologue and initialization of DLLs and so forth, but the interesting part is the line where the compiler basically takes in runtime C# code and compiles it. And in the result, it basically creates from these bytecodes the sample. It's a DLL. Can you move forward?
Yep.
And if you compile it, you will see this in your favorite EDR or whatever ELK that you're using. And this is basically the DLL itself that's being compiled. And once it's run, it communicates automatically with beacons automatically to the Cobalt Strike C2 server. And as you can see, it's like an HTTP request that is looking for a specific pixel with a unique session cookie to communicate with its C2 server. click. Yep. Finally, it gets to this code where the shellcode would be injected to the PowerShell process, and it will be executed in a new thread. And the following code will be the one who will be responsible for the commands which are going back and forth. This is where basically we stopped the attack and compiled all this information and understood after, that's it, you're going? Home? Back to Colombia?
No,
What?
for
Your visa is done? What happened?
I need this. Wait.
Oh, you don't have battery?
Yeah, it's
okay.
like dying. Wait.
And at this point that we understood that we need to compile all this information into like one document. And when we looked for information about the Cobalt Strike beacon, with all these tools, we found out that Russian-speaking ransomware gangs are using it. And when we found out that tools that we were talking about, like AD-Find and so forth, were used by APT threat actors, then linking those two together was only one step ahead of us. So to save our client, we of course did not let the attacker drop the ransomware, but we created this. And this is in our report. As you can see, from November 2020 to an APT actor called Muddy Water, which is from Iran, who used the Ligolo implant on March 21, to the AD-Find from the Hafnium we all know, from the Chinese actor. Using the AD-Find, this is like a small, very low connection. The AD-Find and the NetScan are used in Operation White Stork, which you can read about as well. And as we mentioned, a lot of ransomware groups, mainly Russian-speaking, like Conti, Ryuk, R-Evil, and so forth, were exposed or disclosed or written about by McAfee and so forth in the field, using those type of tools in order to move laterally and attack the network. Those in green, the account restored, the LSAS dumper, and the Ligolo, is the reason that we are standing here today with you, talking to you about it. Hopefully that you will find more information.
One additional thing that I want to mention is that the report that we found related to Ligolo, that was found in the threat actor, Muddy Water, one of the blog posts of Threat Micro. In that report, if you look for that, they were using the open source tool. So we didn't, in this case, they did the modification. So even though could be like small changes, like seems this guy was using a lot of these tools and improving the way, like making this more like faster, avoiding also like sending the commands in, adding the C2 server in the command line. So this guy said, no, I'm going just like double click and that's it. Wait.
So actually we can look at an attacker that is quite sophisticated, have red team experience with the reverse tunneling. This is coming from the pen test side. And we can see also that it's closely related to Russian-speaking ransomware gangs. And we want to also forward the fact that these type of relays need to be blocked, and this type of attack chain need to be taught or need to be educated to your security teams to ensure that this is not happening on your place as well.
Yeah, so as I was mentioning during the talk, almost all the tools, the access that this threat actor got into the infrastructure was gotten via stolen credentials. So that's why, and this is one of the things that we want to leave you in your minds, we cannot rely just on credentials. They compromise one machine and they can get all the credentials from this user, just analyze which is the environment to which this machine can connect, and they can start moving. And this is not difficult. Everything is open source. So have that in your mind. You need just a credential is not enough, so look for additional security controls. It's a must.
Question.
Yeah. So any questions, guys?
Yes.
Yeah, I can repeat. Have you identified the origin of the stolen credentials for the VPN connection?
Yes, we have. As an incident response company, we are also conducting something that is called external surface attack assessment. And we basically look for leaked credentials. We have like the names of the employees and so forth. So we knew exactly from where it came from. It came from an employee in Central America. And they stole her credentials and then moved laterally to installing the proxy. Question?
Okay. First of all, thank you. Very interesting presentation. Just a question on the attribution portion. I know it's very tricky to do attribution in ransomware. And I realized that you mentioned there, for example, adfinds related to like 3 or 4 different groups. You also mentioned an Iranian group. You mentioned the Chinese one. But then in the end, you tell us that it's most likely Russian sponsored. I see that there's also like some language. But are there any additional reasons why you would tie, like you see a specific variation of the adfind or something like that that would tie it more?
So it's a little bit of a politically correct answer. If you look at the headline, you will see that we wrote, and you know, when you are a person that practice public relations, you have to be very accurate with the words that you put in. So we said APT, like linking APT actors with Russian-speaking ransomware gangs. So the APT actors, we don't say that they are cooperating with each other. We just linked the tools together because we believe that the Russian-speaking ransomware gangs are taking tools that are used by APT actors because they think they are efficient. So they look at, for example, the use of Ligolo by Muddy Water and say, oh, this is a really good idea. We should implement Ligolo as well. However, we will craft it our way. But in our opinion, they learned about the use of Ligolo from there, because they are basically practicing creating malware, not pen test. And Ligolo is more, you know, from the red team side. So this is our aim. I hope I answered the question. Another question? She can run all the way there if you raise your hand. Let's try. Someone from the back, raise your hand. Oh, yeah. Run along. Sorry, I'm kidding. Should have placed a man here that we could.
I just wanted to ask, is there any reason why you use like Goland function names instead of some like Win32 APIs calls to detect the malware activities? I mean, in your YARA signatures, I mean, it's pretty easy to bypass those, as you can change the function names, and still the malware would not be detected by your signatures. And instead, like using Win32 APIs, you could potentially, you know, get your signatures reused or things like that.
Like in this case, to create the signatures.
Maybe you repeat the question so everybody will understand.
Okay, as far as I understood, correct me if I misunderstood. Just want to clarify the question. So basically, you're asking why we choose a specific strings for the malware samples and why we didn't rely on the Windows APIs. That's the question. Sorry, I didn't.
Yeah, more or less.
Okay, perfect. So to answer that question, actually, it's based on the way the binaries are like compiled, at least in Go. All the binaries that we found, we saw that they actually are very verbose when you extract the strings from this kind of threads. Okay, so it is. We found like it was easier, at least, and also that's something that we want to share here is like YARA rules have some, one of the the power of YARA rules is that they work for machines, but also for humans. So if we create a rule that probably we as a humans don't understand, probably is more difficult to share the intelligence. In this case, if you are doing an analysis and you see one of those strings, at least you can recollect, and also, so we are also sharing that kind of intelligence, okay? So that's why, first, all the binaries actually contain those strings, And we found more correlation between the strings than the actual APIs. And also we want to share the intelligence if you are doing the analysis. So it works in both ways, so for the human and also for the machine.
I think it's worth mentioning that if you create a YARA rule based out of opcodes, you will be far more accurate.
Yeah.
However, there is a bigger risk that you will miss something. So yes, we also use opcodes, but in this case, as Felipe mentioned, we want to make it approachable for other researchers.
Yep. Does it solve the question? Okay. Any other question, guys? Oh, there.
So in the case you described, did the attackers, were they successful in performing the next stages of the attack on any of the endpoints or not really? And if not, what actually prevented them from doing so? Was that any no direct routing to the internet or some enterprise proxy or something else was effective against going to the end of the chain?
Unfortunately, they were successful at surprising us. However, thanks to security layers in place, we are able to stop them before they were at the last part of actually deploying the ransomware samples. So we don't have the ransomware side. However, we are 99.9% positive that this was basically the next part after the Cobalt Strike beacon or the shellcode deployment. So was there a security in place? Yes, I was talking about the isolation feature, which assisted us a lot. We had this automated, as well as forensics tools like taking memory dump remotely and like file snapshots and so forth to understand how it started. When this disease or the attack starts, it propagates very fast. And to collect all the evidence is very hard. So if you don't have those automations that you can reverse back like a recursive to understand, then it's a big fail. But yes, they pretty much succeeded in surprising us.
Okay.
Question? Okay. Guys, thank you very much. You can find us on Twitter, Dark Opcodes. I'm Naor, Security Joes. If you have any questions, we are here. So feel free to come and approach.
Yeah, guys.
Thank you very much.
Also, thank you, guys. Also, I would like to invite you. Tomorrow I'm going to be talking, giving a workshop related to malware analysis and how to deal with Packers. So if you're interested, you are super invited. So let's see you tomorrow. Thanks, guys.
Thank you.